Welcome back once again. In earlier videos, already we have known about the electric dipole, and we have learned about electric intensity due to dipole on axial line and on equatorial line. Now let us see one more concept: torque experienced by dipole in uniform electric field. Students, let us take an uniform electric field. This is what uniform electric field. Uniform electric field. So uniform electric field means the electric field whose magnitude and direction same at every point. Generally, uniform electric field can be represented by a set of parallel lines. Now, in this uniform electric field, let us place a dipole. See here, I will take a dipole. I will take a negative charge here. This is the negative charge, and this is what the positive charge. The separation between negative charge and positive charge, that is represented by 2L. This is what 2L. This is represented at A point, and this will be represented at B point. See, students, in presence of this electric field, both the positive charge and negative charge experience the force. How they will experience the force here? In presence of electric field, this positive charge experience force along the direction of electric field, and in presence of electric field, negative charge experience opposite to direction of electric field density. How it is? Listen here. In presence of this electric field, this positive charge experience the force. That force can be represented F is equal to Q into E. And in presence of this electric field, this negative charge experience opposite to direction of electric field density with same magnitude. With the same magnitude here. Then look at me. Here, positive charge experience force like this, negative charge experience force like this. Here, equal and opposite force are acting. Equal and opposite force are acting. Wherever equal and opposite force are acting, net force on the dipole is 0 here. Because the one force and second force with equal magnitude acting in opposite direction. Right? Now here, just I am going to extend this force in backward direction. In this direction. Look at me. See here, let us consider a perpendicular distance between two forces. What is the perpendicular distance between two forces? BC is what? The perpendicular distance between two forces. And the dipole is placed in a uniform electric field by this angle, theta. Right thing? Here equal and opposite force are acting. Then you can define the torque. Here how to define the torque? Torque can be defined as the product of magnitude of either force and perpendicular distance between two forces. How to define torque here? The product of magnitude of either force and perpendicular distance between two forces. In what way can define? The torque can be defined as the product of magnitude of either force and perpendicular distance between two forces. This force, either you can take this force or this force. Now, F is equal to Kp. Then how to represent? Tau is equal to what? Tau is equal to Q into E into perpendicular distance. So, this I will take equation number 1. Right. Look at me. ABC looks like a triangle. Triangle, which is the triangle? ABC looks like triangle. In this triangle, I will take sin theta. How to take the sin theta here? Sin theta is opposite by hypotenuse. Opposite is BC, hypotenuse is AB. A sin theta here, sin theta equal to AB divided by, sin theta is equal to what? Sin theta equal to BC divided by AB. BC divided by AB. Again, what is BC? This BC can be written AB into sin theta. AB into sin theta. But AB the distance between two charges, that is represented by 2L. Then how to take the distance BC, perpendicular distance? This is 2L sin theta. I will take equation number 2. Very simple. Put equation 2 in equation 1. What we will get? See here, the torque can be taken, tau is equal to. So Q into E. What is BC? BC is 2L sin theta. This is 2L sin theta. But you know dipole moment again. What is the definition of dipole moment? The product of magnitude of either charges and the distance between two charges. That is Q into 2L. That is electric dipole moment. Then how to say here? Tau is equal to what? Tau is equal to P cross E of what value? Sin theta. So this represents what? This represents torque experienced by dipole in an uniform electric field. What it represents? Torque experienced by dipole in an uniform electric field. Then see here, on what factor the torques will depend? The torque experienced by dipole in a uniform electric field depends on the strength of electric dipole moment, the strength of electric field intensity, and the direction in which dipole is placed in a uniform electric field. I mean, more the electric dipole moment, more the electric field intensity, maximum torque is acting. Also depends on by what angle dipole is placed in an uniform electric field. Then question is here, how to take the direction of torque here? The direction of torque is perpendicular to both the electric dipole moment and electric field intensity because it is a cross product. For example, if the case dipole moment is acting like this and electric field intensity is acting like this, right? I mean, it is present along the x-axis, this will be present along y-axis, right? Then how to take the direction of torque here? The direction of torque must be like this. This is the direction of torque here. So how to represent? This is represented by what? In this direction. I mean, I cross J must be equal to A. I cross J must be equal to A. I mean, electric dipole moment and electric field intensity, if they are perpendicular to each other, then torque is perpendicular to both the electric field intensity and electric dipole moment. I said one more point. The torque acting on the dipole depends on in what direction a dipole moment is placed in a uniform electric field. Then let us see here. In different situation, I want to place a dipole in a uniform electric field. Look at my students here. Shall I take? I will take a uniform electric field here. This is what? Uniform electric field. This is uniform electric intensity. I will take like this also. In this situation, I will take like this. Like this. Like this here. Right? Now, in this uniform electric field, I want to place a dipole. This is the negative charge. Then what about this? This is the positive charge. The negative charge and the positive charge both are separated by small distance. And what about this? This is magnitude of electric intensity. Right? In this case, what is direction of dipole moment? Direction of dipole moment is from negative charge to positive charge. This is what? Direction of dipole moment. Right? I mean, electric field intensity and electric dipole moment both are acting in same direction. That is torque theta equal to 0. Right? In this case, I will take like this. I will take a positive charge here, then I will take a negative charge here. Ready? Then the distance between positive charge and negative charge. This is the distance between positive and negative charge. In this case, what is the direction of dipole moment? Direction of dipole moment is from negative charge to positive charge. And what about the direction of electric field intensity? Like this. Here, electric field intensity and electric dipole moment both are anti-parallel to each other. Here, how much angle is available? 180 degrees available. So, come to this equation. What is the magnitude of the torque when taken? Tau equal to P cross E sin theta. In this case, theta equal to what? 0 degree. Sin 0, 0, 0 into P cross E, 0. Then what is the torque here? In this case, torque equal to 0. Right? In this case, dipole moment and electric field intensity both are anti-parallel to each other. Theta equal to 180, sin 180, 0. 0 into P cross E, 0. Then what about the torque here? In this case also torque is 0. What is meaning of this? When a dipole is placed parallel or anti-parallel to direction of electric field intensity, no torque is experienced. Right? Then I want to place a dipole in one more situation. What I will represent? This is the uniform electric field intensity. This is what? Uniform electric field intensity. Right? By what magnitude? This magnitude. Now, in this uniform electric field, I want to take a negative charge and positive charge. That we are calling dipole. Both are separated like this. Right around. Then, what is the direction of dipole moment? In this case, direction of dipole moment is like this, from negative charge to positive charge, negative charge to positive charge. Right? What is the direction of electric field intensity? This is the direction of electric field intensity. Right? Then I will take one more situation. I will take here is the positive charge and here is the negative charge. Again, both are separated by this much distance. Right? In this case, what is the direction of dipole moment? Direction of dipole moment is from negative charge to positive charge. By what value? By P value. Here, angle between electric field intensity and electric dipole moment. What angle is available? Theta equal to what? 90 degree available. Here also what? Theta equal to 90 degree available. So, if theta equal to 90 degree, then come to this equation again. Torque is equal to P cross E sin theta. If theta is 90, sin 90 is 1. Right or wrong? If sin 90 is 1, then what is remaining? Tau is equal to what? Tau is equal to what value? That is P cross E. P cross E. Then what is the meaning of from this? When a dipole is placed perpendicular to uniform electric field or non-uniform electric field, it experiences maximum torque. I mean, when a dipole is perpendicular to uniform electric field or non-uniform electric field intensity, it experiences maximum torque. Then see here, already I said that here equal and opposite force are acting. Net force on the dipole is 0, but it experiences torque tau is equal to P cross A sin theta. And what is the direction of torque here? Direction of torque is perpendicular to both electric dipole moment and electric field intensity. Then, what is the effect of torque here? The effect of torque is a dipole align along the direction of applied electric field. How it aligns? Actually, electric field intensity it goes like this it goes, right? Due to this torque, this dipole align along the direction of applied electric field. How it aligns? This dipole aligns like this situation. I mean, this dipole rotate in a clockwise direction in presence of this uniform electric field intensity. But students here one more thing is arises. Instead of uniform electric field, if non-uniform non-uniform electric field is present, then what happens? If a non-uniform electric field is present, net force acting on dipole is not zero. Along with it experience the torque. For example, shall I take here? I will take a non-uniform electric field here. How to take the non-uniform electric field? See here. First of all, how to represent non-uniform electric field? This may be the non-uniform electric field. This may be the non-uniform electric field. Right? Here I want to place a dipole. Dipole means this is what negative charge, this is what positive charge. This is positive charge. Right? This is what distance between positive charge and negative charge. See here, this positive charge experience force F is equal to what? Q into P. And this may be moving like this, opposite to direction of electric intensity. Is equal to Q into E. Due to non-uniform electric field, net force acting on dipole is not zero. That's why when a dipole is placed in non-uniform electric field, it experiences both force and torque. And the torque also depends on the product of electric dipole moment, product of electric field intensity, and in which direction dipole is placed in a uniform or non-uniform electric field intensity. This is what the torque experienced by dipole in an uniform electric field intensity. Then question is, what is physical significance of this dipole? It is also very important. The physical significance. Actually, students, electric dipole is a compound. Compound means it may be polar or non-polar. See here, this polar and non-polar molecules experience interesting property and interesting application in presence of electric field intensity and in absence of electric field intensity. This is the physical significance. I mean, the polar molecule and a non-polar molecule, they shows interesting property and interesting application in presence of electric field intensity and in absence of electric field intensity. This is physical significance of an electric dipole moment. So, when a dipole is placed in a uniform electric field and a non-uniform electric field, they both experience the torque, but here force is zero, but in this case it experiences both force and torque. This is what concept of torque experienced by dipole in an electric field, either may be uniform or non-uniform electric field. Thank you.